2022 paper 1 question 5, we have to find the derivative of this function. So we can write the function as x squared minus x to the power minus 1. It'll just make things easier because we can use the power rule. So the derivative then will be 2x. Then we bring the power down to the front. So we'll have minus, and then we'll have minus 1 x to the minus 2. We can simplify that a little. So we'll get 2x plus, because the minus times minus 1 just gives us positive. And then you can say 1 over x squared, or you could leave it as x to the minus 2 if you'd like. Then we're told that x plus 1 is a factor of this, so we need to find 3 values of x for which f of x is equal to 0. So basically we're going to have to factorize this, and we know one of the factors is x plus 1. You can do long division if you'd like, but I prefer doing it this way. So when we have x plus 1, if we multiply that by some kind of quadratic whose coefficients we don't know yet, that should give us the cubic, because we know that x plus 1 is a factor. So this will be true always. We just have to figure out what a, b, and c are. So from inspection, we can see that a is going to be 2, because on this side, on both sides, these have to be equal always. So on the right hand side, we have a 2x cubed. So on the left side, we need a 2x cubed. So the only way we can get an x cubed on the left hand side is x times ax squared. That's going to give us ax cubed. And there's no other way to get an x cubed term. So in order for ax cubed to be 2x cubed, a has to be equal to 2. If you didn't spot that, it's fine if you just multiply it all out. You'll get the same answer. It's just that's kind of speeding things up. Then we can multiply out the left side. We'll get 2x cubed, as we wanted. Then we'll have plus bx squared plus cx plus 2x squared. So now we're multiplying the 1 in, plus bx plus c. And that's going to be equal to this stuff. So we don't have to worry about the 2x cubed anymore, because we have that on both sides. We've taken care of that already. But we do have to worry about the rest of the stuff. So let's kind of group the terms together. So let's see our x squared terms on the left side. We'll have b plus 2 x squareds. How many x's do we have? We have c plus b x's. And then how many constants do we have? Well, we just have c. That's our only constant. And that has to be equal to this side. So what we notice is the number in front of the x squareds has to be the same. So b plus 2 must be the same as minus 21. This tells us that b is equal to minus 23. And then we can see clearly the constants are the same, so c has to be equal to 63. And then the way that you can check your answers is the number in front of the x should be the same on both sides. So is it true that c plus b is the same as 40? Well, yes, you can see from here. So now we factored our polynomial. So the cubic now can be written as x plus 1 multiplied by this quadratic. So we have x plus 1 multiplied by the quadratic, which we now know is 2x squared plus b, which is minus 23, x, and we have plus 63. And that's equal to 0. So we're solving equal to 0, and we need the roots. That's what the question tells us. F of x equals 0. So it means that x plus 1 equals 0, which means that x is minus 1. So that's one solution. Or we have that 2x squared minus 23x plus 63 must be equal to 0, and we have to solve that. So you might want to use the quadratic formula, because this is a bit tricky, but it is factorable. So 2 times 63 gives 126, and we can write that as minus 14 times minus 9, and you can see that that's true. And then when you add these things, you'll get minus 23, so that's a good thing to try. But again, minus b formula is completely fine. I probably wouldn't have spotted that. It's just a little nicer way of doing it. Minus 14x minus 9x plus 63 equals 0. And also, even if it probably wastes time looking for factors of such a big number, so yeah, may as well just use the quadratic formula. Anyways, you will get the same answer. We can take a 2x out of these first two terms, and we'll get x minus 7. And then we want to get x minus 7 here, so we don't want to take out a positive 9, we want to take out a minus 9, because then we'll get positive x minus 7 equals 0. If we took out a positive 9, the signs would be switched. So then they both have an x minus 7 in common, and then we're left with 2x minus 9 equals 0. So that means that x equals 7, or x is equal to 9 over 2. They don't say to write it any certain way, do they? Nope. So yeah, these are fine. And then we also have or x equals minus 1, which is from up here. So there's our 3 possible values. They're told to find the range of values for which f prime of x is negative. So f prime of x, we just have to differentiate this. So f prime of x will be equal to, we'll get 6x squared minus 42x plus 40 when you use the power rules. And we want that to be negative. So we want that to be less than 0. And we want to figure out what values of x. So the first thing to make this a little bit easier is we can divide everything by 2. And we'll get 3x squared minus 21x plus 20 is less than 0. And now basically what we have to think about is, right, this is a positive quadratic, which means it's going to look like this. it's going to have two roots, and this is the y value, right? So this is f prime of x. So we want this to be less than 0. So if we graph f prime of x on the y-axis and x on the x-axis, basically what we want is we want this part here, because that's where the y value is negative. So we need to find the two roots, and then in between the two roots is where f prime of x will be negative. So we just need to solve the quadratic. It doesn't factor very nicely, and you could probably guess that because it's correct 2 decimal places. So we can figure out for the roots, we'll have x will be equal to 21 minus b, plus or minus the square root of 21 squared minus 4 times 3 times 20. So the reason this is 21 and not minus 21 is because it's minus b, but b is minus 21, so minus minus makes it plus. All divided by 2a, so that'll be all divided by 2 times 3. And then the two answers you'll get to 2 decimal places when you do the plus and the minus is you'll get 1.137, or you will get 5.862. So in reality, our diagram's a little wrong because they're both positive. It probably looks a little more like that. So the reason I've written 3 decimals here is because you have to be a little careful. Now, I don't know if they'd actually make you look into this level of detail. In this example, you round it and it ends up being fine, but just to be very rigorous about it. If we look at these 2 points, this is 1.137, and here we have 5.862. So if we round this, if we round the 1.137 to 1.14, that's going to be like here, right? And here it's still negative, so that's good. And when we round this down, it's going to be like here, and that's still negative, so that's good. However, let's say we had like 0.134. Well, then that if we round this down, we're going to end up rounding it down, so we're going to end up here. And here, it's not negative, it's positive. So we actually can't round it down if it was 134. We'd have to round it up to be 1.14, because if we round it down, it's not always going to be negative. But if we round it up, it always is going to be negative. Again, would they make you have that much detail? I don't know. But in this case, you just round them, because rounding up is the correct on the left, and rounding down is correct on the right. And it's still going to be negative regardless. So basically, you want x to be between these two values. So x will be in between 1.14 and 5.86, and that's our range of values of x.